Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the properties of salts. In our last lesson, we learned about some important salts and their uses. In today's lesson, we will discuss the general properties of salts. We will also describe a chemical test of some salts by conducting an activity. Let us begin by discussing the solubility of salts. Salts can be classified based on the negative ion or anion they possess. This is because the anion is responsible, in part, for the solubility of the salt. This table shows some simple observations about the solubility of certain groups of salts. For example, all nitrates, perchlorates, chlorates, and acetates are soluble without exception. Most halides and sulfates are soluble. However, there are some exceptions. Carbonates, phosphates, and sulfides of alkali metals and ammonium ions are soluble, but carbonates, phosphates, and sulfides of other elements are insoluble. Also, all sulfides of alkaline earth metals are soluble. Salts can also be classified based on their tendency to absorb water from the atmosphere or to release it into the atmosphere. Hygroscopic salts are those which absorb water from the atmosphere but remain solid. Deliquescent salts absorb water from the atmosphere to form a solution. The process is known as deliquescence. It is important to note that while all deliquescent substances are hygroscopic, not all hygroscopic substances are deliquescent. Efflorescent salts lose their water of crystallization to the atmosphere. This process is known as efflorescence. When soluble salts are in aqueous solutions, they are good conductors of electricity. This is because they release mobile positive and negative ions in solution. For example, the dissolution of sodium nitrate produces sodium plus and nitrate ions. The dissolution of calcium chloride produces calcium 2 plus and chloride ions. Students, let us do an activity. Please define the terms hygroscopic salts, deliquescent salts, and efflorescent salts. What is the difference between hygroscopic salts and deliquescent salts?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I wonder how accurate your definitions are. Let us discuss each one together so that you can check your answers. Hygroscopic salts are those which absorb water from the atmosphere but remain solid. Deliquescent salts absorb water from the atmosphere to form a solution. The difference between the two is that one remains a solid while the other forms a solution. All deliquescent substances are hygroscopic, but not all hygroscopic salts are deliquescent. Efflorescent salts lose their water of crystallization to the atmosphere. Did you define each term correctly? If so, well done. If not, please correct your answers. Another property of salts by which they can be classified is their thermal stability. It is possible for salts to contain an identical anion, but display different behavior when heated. While some salts are thermally stable, others undergo decomposition. Let us discuss some examples. Carbonates are salts that contain a carbonate as an anion. Carbonates of many transition metals, as well as those of group 2A metals, decompose when they are heated. When this occurs, metals oxides and carbon dioxide are produced. For example, when magnesium carbonate is heated, it decomposes to magnesium oxide and carbon dioxide. When copper 2 carbonate is heated, it decomposes to copper oxide and carbon dioxide. In contrast, when carbonates of sodium and potassium are heated, they do not decompose. Nitrates are salts that contain a nitrate as an anion. If the nitrates of most transition metals, or the nitrates of group 2A metals, are heated, they decompose. This produces a metal oxide, nitrogen dioxide, and oxygen. For example, when magnesium nitrate is heated, it decomposes to form magnesium oxide, nitrogen dioxide, and oxygen. When lead-2 nitrate is heated, it decomposes to form lead oxide, nitrogen dioxide, and oxygen. When nitrates of sodium and potassium are heated, they decompose to give nitrites and oxygen gas. As you can see from this equation, sodium nitrate decomposes on heating to form sodium nitrite and oxygen gas. Potassium nitrate decomposed when heated to give potassium nitrite and oxygen gas. However, the carbonate and nitrate of lithium are different from those of sodium and potassium. When they are heated, they decompose as you see here. Lithium nitrate decomposes to form lithium oxide, nitrogen dioxide, and oxygen. Lithium carbonate decomposes to form lithium oxide and carbon dioxide. Students, now let us continue our discussion on how we can identify some ions in salts. The first one is a flame test. A flame test is a procedure used to identify the presence of lithium, sodium, potassium, calcium, strontium, and barium ions in salts. This is done by heating their solid or moist salts directly in a Bunsen flame. Certain metals will give the flame a characteristic color. In order to do this, a small amount of the salt is placed on a watch glass. Then it is moistened with hydrochloric acid. Then the tip of a nichrome or platinum wire is dipped into the moist salt and placed into the flame. This chart shows the colors that will be produced from the metals present in different salts. Students, think about the fireworks that you have seen. In groups of 3 or 4, determine how fireworks get their coloring based on the flame test we just discussed.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure that your group thought of some great answers for this activity. Fireworks get their coloring from the different compounds they contain. Different compounds produce characteristic flame colors. Therefore, when fireworks are produced, they can be created to display specific colors. For example, fireworks that contain strontium compounds will produce crimson flames, and fireworks that contain copper compounds will produce flames that are a bluish-green color. In this lesson, we learned about the properties of salts. We also looked at the flame test, which shows the metal compounds that are within different salts. In our next lesson, we will learn about fertilizers and pesticides. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.